Alright guys, let's continue where we left off from the last video. So in the last video, we went over formulas that we use when we're doing trigonometric substitution. Before we get started to see what examples we could see with trigonometric substitution, let's see why we do trigonometric substitution. Okay, say we're giving the integral from 0 to 2 of square root of 1 plus 4x dx. Okay, so there isn't any analytical method for solving this, actually, for solving this integral. Okay, at the time, of course, but due to the why is this the case? It's because of this 1 plus the plus, right, inside the square root. So it would be much nicer if we could have factors inside the square root, okay, to cancel the square root out. Okay, so to solve this problem, trigonometric substitution came into play. Okay, so let's have a look at the different three cases that we can come across. So case one, again, if you saw the last video, this is the same formula that same order we're gonna go with the formulas. Okay, so case one is when we get a squared minus x squared. Okay, when we see something like a squared minus x squared. Okay, so what do we do, right? So first we write down what the x would be equal to. So the x in this case would be equal to a sine theta. Again, a is a number, okay? And dx is going to be equal to, again, the derivative of x is a cosine theta d theta. Okay, so x and dx. Next, we're gonna see an example with this. Okay, again, remember, if you see a squared minus x squared, remember it's sine theta. You're gonna have sine theta when x when x is equals a sine theta. Okay, so let's have a look at an example. Say we're given the integral to find 1 over square root of 16 minus x squared dx. Okay, again, just solving this without trig substitution would be a kind of impractical, impossible to do, because trig substitution is needed to get that square root, to get it out of that square root. Okay, so what can we do? So for first step, recognize that this is a squared minus x squared. Okay, a squared minus x squared, and recognize that a squared minus x squared is something related to sine theta. Okay, so what would a be in this case? A would be 4, because remember a is squared, right? So that's why we get that 16 over there. Okay, we also have to find our x, what our x would be equal to. Okay, x would be equal to 4 sine theta. Remember, a is just a number, right? A is just a number, and dx is going to be equal to 4 cosine theta d theta. Okay, now let's sub it in. Here comes the trig sub part, where you would see how things kind of cancel out. Okay, so square root of 16 minus x squared. So what is x again? We're going to plug in x. So x squared, so 4 sine theta, okay, squared. This is going to be squared. Okay, next step, times, we're going to do, what is dx? Our dx is 4 cosine theta, right? 4 cosine theta d theta. Okay, our next step would be kind of to simplify this, to see how this kind of breaks out of the square root. Okay, so 16 minus 4 square is 16, sine square is just sine square theta, times 4 cosine theta d theta. Okay, next step is to factor the 16 out. Okay, if I take a factor of 16 out, so it's going to be 1 minus sine squared theta, right? 16 times 1 is 16, 16 minus 16, right? Okay, so I took out that 16, right? And what is left, right? If I take that 16 out of the square root, right? So we have to square root that 16. It's going to be 4. If I take that 16 out of the square root, we have to take the square of that. Now we're going to be left with 1 minus sine squared theta inside the square root. Okay, again, we're going to multiply that with what we got as our dx, which is 4 cosine theta d theta, right? Next step, recognize. Recognize this gives us, goes back to one of our formulas. You guessed it right. It's our cosine squared theta formula. Okay, cosine squared theta. Cosine squared theta equals to 1 minus sine squared theta, guys, by the way. Okay, so this is going to be cosine squared theta times 4 cosine theta d theta. Okay, now the squares are going to cancel. The square root and the square is going to cancel, and we're going to be left with 4 cosine theta. Okay, 4 cosine theta d theta. Now, do you see how it's going to cancel? How things are going to start to cancel? Yeah. What are we left with? We're left with, oh, we're not going to cancel the d theta. D theta is still going to be over there. We're left with integral of d theta. Wow, that's really simplified. Okay, now we know we could do normal integration, right? So the integral of d theta is theta, right? And we got to also include the plus c, guys. Do not forget. But we are not over. We are not over yet. So we got to do it in terms of x. Okay, this is in terms of theta, right? So let's go back and see if we could somehow get what our theta was. Okay, so we have a look at this. X equals 4 sine theta, and let's take this down. Okay, let's move this down. X equals 4 sine theta, and see if we could get the theta to one side so that we can plug it into our theta answer, right? So if we divide 4 both sides, it's going to be x divided by 4 equals sine theta. Now, if we take the inverse of both sides, okay? Inverse of both sides is going to give me sine inverse of x over 4 equals theta. Okay, so we found out our theta value. Now, we could plug in the theta value into this answer. Okay, so it's going to be sine inverse of x over 4 plus c. Now this is our final answer. Okay, now let's have a look at the second case. Second case is when you come across something like a squared plus x squared. Okay, a squared plus x squared. A squared plus x squared. If you see something like this, your x is going to be a tangent theta. Okay, it's like how we had a sine theta. When you have a squared minus x squared, you're going to have a tangent theta, and the derivative of this is going to be a secant square theta d theta. Okay, so you're going to see some similarities with what we've been doing with sine theta. Okay, but let's have a look at an example to see how we can sub in x equal for tangent theta and how it's going to cancel out. Say we've been given the integral to find 1 over 1 plus x squared to the whole square, okay, dx. Okay, step number 1, recognize that this looks like a squared plus x squared. Okay, recognize that. Okay, recognizing that is going to be our first big step. Okay, a squared plus x squared, that looks like a squared plus x squared, and we also know a squared plus x squared is when we can put in something like tangent, right? We can put in something like tangent. So that's our first step. Next step, know what your a value is. A value in this case, since 1 square is just 1, a is going to be 1, x is going to be a tan theta, so it's just going to be 1 tan theta, and dx is going to be 1 derivative of tangent is secant square theta. Alright, that matches up with our formulas. D theta. Okay, next step, sub in the x. So 1 over 1 plus, what is our x value? So 1 times tangent theta is just tangent theta square to the whole square. And dx is just going to be 1 times secant square, which is just secant square theta d theta. Okay? If you look over here, 1 plus tangent theta square, what does that look like? That looks like secant square theta to theta square. Okay, 1 plus tangent squared. Okay, that equals to secant square theta. Okay, and we're going to multiply that with secant square theta d theta. Okay, now we're going to be left with secant square, squeeze secant to the 4th theta times secant square theta d theta. We're going to be left with integral of 1 over secant square theta. Okay, what do we know 1 over secant equals? We know that equals cosine theta, right? Similarly, 1 over secant square theta is going to be equal to cosine square theta. So we got to kind of relate that also over here. Okay, of course, d theta, we got to mention the d theta also. So this is going to be integral of cosine square theta d theta. Okay, now that we know, now that we've come here, the next step is going to be to also recognize that cosine square theta, we're going to go back to our half angle identities. Our half angle identity says that cosine squared theta equals to half of 1 plus cosine 2 theta d theta. Okay, guys, a lot of formulas, identities that we've done in the past that we're going to kind of include over here. That we're going to kind of plug it in over here. Okay, so we're going to be left with half integral of 1. Okay, let's find the integral. Let's just directly find the integral over here. So integral, we're going to bring the half outside. Integral of 1 is going to be theta, since we're doing with reference to d theta, plus integral of cosine 2 theta. Okay, first we're going to do, so this is kind of like cosine 2 theta. Okay, so integral of the outside is sine 2 theta over the integral, or integral of inside. Oh, sorry, the derivative of inside, which is going to just be 2. Plus c. So this is our integral, guys. Next step, kind of recognize that first, what is our theta value? Let's go back to and find our theta value. So we're going to bring our x equals whatever it was, x equals tangent theta, and take the inverse of both sides. If you take the inverse of both sides, you find out that theta equals tangent inverse of x. So that's what our tangent inverse of x is, but we got to find the sine. So to find the sine, we're going to go in the corner and create a table over here. Okay, create a table, and where theta is going to be over here, and we found out that theta equals to x equals to tangent of theta, right? So tangent equals x perpendicular over 1, because x over 1, right? Tangent perpendicular over base. And if you do the Pythagoras theorem, right, you're going to find out that this third side is going to be 1 plus x squared. Then we figure out that our sine 2 theta, we know, is equal to 2 sine theta cosine theta. Okay, so that's why we get 2 sine theta, which is x over square root of 1 plus x squared, times cosine theta, 1 over 1 square root of 1 plus x squared. Okay, those cancel out, and we're left with half tan inverse of x plus x over 1 plus x squared. Okay, guys, so that is our final, and plus c. We should not forget to mention the plus c. Okay, guys, that is our final answer. I hope you did get a firm understanding of trig substitution. In the next part, we will go over the third case and the final case, which is x squared minus a squared. Okay, opposite of sine theta, and which is gonna be secant theta. Okay, it's x squared minus a squared. So stick around and join me in the next video as we have a look at x squared minus a squared. Please like, share, and subscribe. Thank you so much.